This is for Chapter 11 significance tests. A test of significance is a formal procedure for comparing observed data with a hypothesis whose truth we want to assess. There's 4 parts to each test of significance. The first one, you state the name, hypotheses, and define the parameter of interest. Then you check your 3 conditions. Then you pick a formula and show your calculations. And then in the last step, you interpret your findings in context. So in this example problem, it says that Mr. Murphy thinks that 56% of all high school seniors are registered to vote, but you think the proportion is lower. Taking a sample of 40 students, you find the proportion to be 52.5%. A test of significance will determine if this difference is big enough to say the true proportion is lower than 56%. So in the first step, you state the name of the test, which is a 1 proportion z-test for a population mean at alpha equals 0.05. And then you state your 2 hypotheses, which are the null hypothesis and the alternative hypothesis. The null hypothesis is the statement of no change, the statement that's being tested and that is assumed to be true. In this case, it is p equals 0.56. The alternative hypothesis is the claim that we are trying to find evidence for in this statement that we suspect to be true. It can be one-sided or two-sided. In this case, it is one-sided, and it states that p is less than 0.56, and p would be the true proportion of seniors that are registered to vote. Then you check your 3 conditions that must be met in order for the test to be valid. It asks that your data comes from an SRS, which is stated in the problem or not. In this case, it is. And then it asks for normality, or at least 10 successes and at least 10 failures, and that is met in the problem. And then it asks for independence, and in this case, you can assume that there are more than 400 high school seniors. Then you choose a formula and show your calculations. So the formula that we'll use for this problem is in the top left corner, and then if you plug in the problems next to it on the right, the 0.525 value comes from the 52.5% that was stated in the problem, and then you subtract the original value of that 56% that Mr. Murphy believed. And then you divide that by the square root of the 0.56 times 1 minus 0.56 divided by n, which in this case is 40. And that statistic comes out to negative 0.4459. Then in order to find your p-value, you use your calculator function and a sketch. In this case, we would shade left to the found test statistic because the alternative hypothesis states that p is less than 0.56. So on the calculator, you use normal CDF, and inside the parentheses, you use negative infinity, your test statistic, which was found above, which is negative 0.4459, the mean and standard deviation, which in this case are 0 and 1, and that comes out to 0.3278, and that is also your p-value. In the final step, you interpret your findings in context. So in this case, it would be, since the p-value equals 0.3278 is greater than alpha equals 0.05, we fail to reject the null hypothesis and conclude that the true proportion of high school seniors that are registered to vote is 56%, and this test is only valid if all conditions are met, which in this case they were. Then going into power and error, power is the probability that the test rejects the null hypothesis in favor of the alternative hypothesis when it should. And in order to find power, you can do 1 minus beta, or beta equals 1 minus power. And then for error, there's 2 types of error. A type 1 error is rejecting the null hypothesis when it is true, and alpha equals the probability of a type 1 error occurring. And then a type 2 error is failing to reject the null hypothesis when it is false, and beta equals the probability of a type 2 error occurring. This is an example of how to find the power. The values are from another problem, but you can still see how it's done. So in step 1, you state both hypotheses, alpha, standard deviation, n, and the specific alternative, which would be given to you in the problem. In step 2, you find the values of x bar that will lead you to reject the null hypothesis. You can either use the formula under A or the calculator function of inverse norm, and you would do 0.95. Then the mean, which is 25, then the standard deviation divided by the square root of n, which here is 3 divided by the square root of 40, and you get 25.7802. And this means that there's a 5% chance that x bar will equal 25.7802 when the mean is 25. Then in step 3, you're going to calculate the probability of observing these x bar values when the specific alternative is true. So for this part, you use the calculator function normal CDF and plug in that x bar value of 25.7802 to infinity. Then you would use the alternative or the specific alternative as the mean, and then the standard deviation divided by the square root of n. And that comes out to 0.9354.